Hi everyone, this is Dr. E. Sridevi, Professor, Department of Electronics and Communication Engineering. In this video lecture, we are going to learn about capacitor and parallel plate capacitor. So on completion of this module, the learners can able to understand the definition of parallel plate capacitor and basis behind this parallel plate capacitor. While talking about the definition of parallel plate capacitor, it consists of two large parallel conducting plates. These two plates are separated by a small distance. It stores electric energy when a potential difference is applied across the plates. Potential difference is nothing but the voltage. So basically, what is a capacitor? Two conductors separated by an insulator. Insulator is nothing but the dielectric material. Stores electrical energy in an electric field. Plates carry equal and opposite charges plus Q and minus Q. Here, this is the formula of capacitance, that is the air or vacuum between two plates. C is noted as C is equal to epsilon naught A divided by D, where C is the capacitance in farads and A is the area of one plate, that is noted as meter square, and D is the separation between plates, noted as meter. Epsilon naught is the permittivity of free space, which is given by the numeric constant, that is 8.854 into 10 power minus 12 farad per meter. And with the dielectric material, if capacitance epsilon is inserted, it is noted as C is equal to epsilon A divided by D, where epsilon is equal to epsilon naught epsilon R. And here epsilon R is called as relative permittivity of the dielectric constant. Electric field between the plates E is equal to sigma divided by epsilon naught. For air or vacuum, it is called as E is equal to V by D, where V is the potential difference and C is the charge stored. So Q is equal to CV. The energy stored in the capacitor. Let U or E is the energy stored in the capacitor. It is noted as U is equal to 1 by 2 CV square. That is equal to 1 by 2 Q into V. So Q square divided by 2C is the energy stored in the capacitor. Let us have one problem based upon this. Two parallel plates of each area is noted as 0.2 meter squares are separated by 4 mm. Find the capacitance. It is given as distance is given as 4 mm and area is given as 0.2 meter square. So substituting this distance and area in this formula, C is equal to epsilon naught value is the constant value, which already we know that 8.854 into 10 power minus 12, and A value given and D is also given. Substituting this all values in C formula, C is equal to epsilon naught A divided by D. So the capacitance value is called as calculated as 4.427 into 10 power minus 11 farads. So while writing this one as a constant picofarad range, it is noted as 44.3 picofarads. So this is called as capacitance in series. So series means same in all plates. So that means right plate of each capacitor consists of left plate of the next. So only one path here, same current flows through all the capacitor, means that is called a series connection. So it is called a series connection. So equivalent capacitance of seriously connected is known as 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. It is the formula to calculate equivalent capacitance when three capacitors are connected in series. Similarly, this is called as parallel connected capacitors. So C1, C2, C3. Here voltage, all capacitors share same voltage. Here previously different voltages, here same voltages. So here our voltages are shared same, means all left plates connected together, all right plates connected together. So same voltage across each capacitor is called as parallel capacitor. The equivalent capacitance connected in parallel is given as C equivalent is equal to C1 plus C2 plus C3. So C equivalent for three capacitors are connected in series, then it is known as 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3, and for parallel it is noted as 1 by C equivalent is equal to for parallel it is called as C equivalent is equal to C1 plus C2 plus C3. For parallel same voltage is flowing, and for series it is divided. So here these are the diagrams of 3 capacitors are connected in series and 3 capacitors are connected in parallel. So C1, C2, C3 same current flows, then it is called a series, and C1, C2, C3 different voltage there means that is called as parallel. So we have one problem. C1 is given, C2 is given, C3 is given, and 3 capacitors are connected in series, and you are asked to calculate the total C equivalent. So 1 by C equivalent is equal to C1 given, C2 given, C3 given. Substituting this C1, C2, C3 and finding 1 by C equivalent. This is this one, and finding C equivalent means 1 by taking inversion. It is 1 microfarad, that is 1 into 10 power minus 6 farads. So this is all about that one. So next problem is 3 capacitors are given, and you are asked to calculate the parallelly connected, and you are asked to calculate the net capacitance. So calculating the C equivalent, that is equal to V1 plus V2 plus V3 is asked to find. So calculating this V, then C is known as C1, C2, C3. Here total equivalent value is equal to adding this 3, that is equal to 10 plus 4 plus 6, and this final value is equal to your C. And finding the charge value, charge Q is equal to Q1 is there, Q2 is there, Q3 is also there. So final charge is equal to addition of these 3, that is the charge behind the capacitor. Applications of capacitor: it is used for energy storage, signaling, signal filtering, turning circuits or tuning circuit, transient suppression circuits. All the capacitors are used. Hope you all understand this basic concepts behind capacitor and how to calculate the equivalent capacitor when it is connected in series and parallel with the help of the formula set. And thank you for listening.